In this video, I will show you how to use slope and length to determine whether or not two segments are perpendicular, parallel, congruent, or whether or not they bisect each other. And then we will use that same technology to prove that this quadrilateral is a rhombus, and we will also verify a property about a rhombus. And we will then prove that this quadrilateral is a kite, and we will verify one of the properties of a kite. Okay, so 16 part A. First we need to determine if these are perpendicular. If you want to know if two segments are perpendicular, you need to know the slopes. If they are perpendicular, the slopes will be opposite and reciprocal. So that's what we need to check. So let's start with the slope of PQ. So slope of segment PQ. Okay, now we know that slope is y minus y over x minus x. So that's going to be 4 minus 2 over 3 minus negative 3. So 3 minus negative 3. We have learned that minus and negative is really addition. Okay, so this is going to give us 2 over 6, which simplifies down to 1/3. Alright, that is the slope of segment PQ. Now let's find the slope of segment QR. Alright, again, it's y minus y over x minus x. Okay, so that's going to be 1 minus 4. Okay, yeah, 1 minus 4 over 4 minus 3. Okay, 1 minus 4, that is negative 3, and 4 minus 3 is 1. Okay, so that's just going to be negative 3. Now, these are reciprocals of each other, and you can almost best see it right here because I have 1/3 and then I have 3 over 1. They are also opposites because one's positive and one's negative. So since these are opposite and reciprocal, then these are perpendicular. So I'm definitely going to circle true. Okay, now they said justify with calculations and words, so here come the words. Since slopes are opposite and reciprocal, segment PQ is perpendicular to segment QR. Okay, now let's talk about whether or not segment PQ is parallel to segment SR. Okay, so we have segment PQ showing up again. So we already know the slope. Alright, so slope PQ is equal to 1/3. We already know that from the previous problem, so I'm just going to copy that down. Alright, so now we need to find the slope of SR. Okay, if these turn out to be equal, then they will be parallel. If they're different, then they're not parallel. So let's see, SR, that's these two. So again, I'm doing y minus y. So that's going to be negative 1 minus 1 over x minus x. So negative 4 minus 4. That's going to be negative 2 over negative 8. So that's going to be positive 1/4. Okay, since these are not the same, then that means that these are not parallel. So this is going to be false but now it's time for my summary statement. So I can say since slopes are not the same, segment PQ is not parallel to segment SR. Okay, so now I need to talk about PS and QR. Alright, let me start with, so now we're talking about congruent. So that's not a slope thing. If they're congruent, then that means that their lengths are equal. So I need to find the length of each one of these. So let's start with PS. And I can say, if I just write PS like that with no segment symbol, that automatically means the length of segment PS. So I'm good to go. The formula for length, maybe I'll just write this down off to the side real quick. The formula for length is x minus x squared plus y minus y squared. It's the distance formula, the length formula. So that's what I'm doing. So for PS, okay, so here's P and here's S. So focus on that. Okay, so I'm doing x minus x. Now the order really doesn't matter. I guess I'll just keep doing x2 minus x1. So I'll have negative 4 minus negative 3 squared. Okay, and now here comes y minus y. So negative 1 minus 2 squared. And I've got the square root of all that. Alright, I'm just going to use a calculator to help me out a little bit. Okay, so the part underneath the radical, I have negative 4 minus negative 3. You know, I could have put just plus 3 because that's the same thing. Squared plus negative 1 minus 2 squared. That's 10. Alright, that means I have radical 10. Okay, that is the length of PS. So now I'm going to do the same thing for QR. Alright, again, I'm doing x minus x squared. So let's see, so now I'm doing QR. So let me change my highlighting. Alright, QR, that's these two. So x minus x, so that'll be 4 minus 3 squared. And then y minus y, so that's 1 minus 4 squared. Okay, well look, 4 minus 3, that's 1. You know, so what I really have is 1 squared. 1 minus 4 is negative 3. So this is really going to be 1 plus 9, right? Because 1 squared is 1 and negative 3 squared is positive 9. And guess what? That's 10, square root of 10. Alright, so I'm just going to compress this down so it all matches up. Alright, so this turned out to be the square root of 10. So of course that means that it's true that these are congruent. Okay, so I'll just write a few words. So I can say since lengths are equal, segment PS is congruent to segment QR. Okay, now, do these segments bisect each other? As soon as I see that phrase bisect each other, my mind yells midpoint. If two segments bisect each other, that means they cut each other in half, which means they meet at the same midpoint. So that's what I need to do. I need to find the midpoint of each one and see if it's the same. So first I'm going to find the midpoint of PR. Alright, the midpoint of segment PR. Okay, so for midpoint, and again let me just do this off to the side, it's the average of the x's, okay, comma, the average of the y's. Alright, that's how you find the midpoints. That's what I'm about to do. Okay, so PR. Alright, let me get my highlighting game together. So PR. So first the x's. So negative 3 plus 4. So I've got negative 3 plus 4 over 2. And then now the y's. So that's 2 plus 1. Divided by 2. Okay, so that's going to be negative 3 plus 4 is 1. So that's going to be 1/2. And 2 plus 1 is 3. So that's going to be 3/2. Okay, so that is the midpoint of segment PR. So now I need to do the same thing with segment QS. Okay, so let's see, QS. Alright, so let me change my highlighting. So here's Q and here's S. So first we have the average of the x's. So 3 plus negative 4. Okay, and now I have the average of the y's. So 4 plus negative 1. Alright, so that's going to be negative 1/2 and 3/2. Okay, that is really close, but this was positive 1/2. Comma 3/2, and this is negative 1/2. So those midpoints are not the same. So here I've circled false, and I added in my summary statement. Since midpoints are not the same, segment PR and segment QS don't bisect. Okay, for problem number 17, we need to prove that quadrilateral ABCD is a rhombus, of course using the definition. Whenever you prove something, you need to have an introduction, your calculations, and then your conclusion. So the introduction, basically, we state our strategy. How will we prove this? Well, let's start with the definition of a rhombus. The definition of a rhombus says we have 4 congruent sides. So that is our strategy, is to prove that we have 4 congruent sides. Okay, so let's write that down as our introduction. I'm spelling the number 4 wrong. That's not a good sign. I will show all 4 sides congruent. That's my introduction. So now let's do those calculations. So if I'm going to show the 4 sides congruent, that means I need 4 lengths. So here I go. Let's start with AB. Okay, and because I have the graph given to me, I'm going to treat it. Oh, you know what? This is horizontal. I started to talk about doing a Pythagorean theorem, but if it's horizontal or vertical, we can really just count the squares, right? So this is horizontal, so I can see that I have 4 units to the right and 1 unit to the left. So I can see that that's 5. So AB, the length of segment AB is 5. So I've got that. So let's keep going. What about, let's go ahead and do BC. I'm just going to go around the clock. So let's do BC now. So if I just write BC next to each other with no segment sign, that means the length of BC. So I'm going to go ahead and do the Pythagorean theorem this time. So I can do it like this. If I make a little right triangle where BC is the hypotenuse, then this is 3 and this is 4. Now I've memorized the Pythagorean triple 3, 4, 5. So I know this is going to be 5. But if you did not know that, or if you just have to show your calculations, then I would put the square root of 3 squared plus 4 squared. But I assure you that that will turn out to be 5. Okay, so now I know that that's 5. Okay, let's go around the clock, and now I'm looking at DC. And this is horizontal again, so I can just count. And that's 4, 5. Okay, so that takes me to AD. And I'm back to doing the Pythagorean theorem again. I'm back to making a little right triangle out of it. Now this vertical piece is 4 and the horizontal piece is 3. Alright, so I'm back to doing 3 squared plus 4 squared. And again, this is a 3, 4, 5 triangle, or if you put this in your calculator, you're going to get 5. Alright, so all 4 sides were equal to 5. So that's the body, my calculations. Now it's time for the conclusion, the summary statement. So since all 4 sides are congruent, ABCD is a rhombus. That's my conclusion. Alright, let's move on to part B. Use calculations and words to verify one property about the diagonals of a rhombus. Well, the one thing I know about the diagonals of a rhombus is that they are perpendicular. They are also lines of symmetry, but this is the main one. Diagonals of a rhombus are perpendicular. So how do you prove that 2 things are perpendicular? Well, you show that their slopes are opposite and reciprocal. That's our strategy, so that should be our introduction. Okay, so I will show that the slopes of the diagonals are opposite and reciprocal. Okay, so my introduction basically states the strategy that we're going to use to prove whatever we're trying to prove. Okay, so now let's go ahead and do it. So the diagonals, there are only 2 diagonals, so that makes it a little bit easier. The diagonals are AC and DB. Okay, so here's AC right here. Okay, so let's talk about the slope of AC. Okay, slope of segment AC. In fact, let me just go ahead and talk rise over run. So from A to C, I'd have to go down 4, right 2. So rise over run, that's negative 4 over and positive 2. Did I just put a negative sign on that? It's negative 4, positive 2. Down 4, right 2. Okay, so rise over run. And that is negative 2. So that is the slope of segment AC. Alright, now let's talk about the slope of the other diagonal, which is dB. Okay, so here's dB. Alright, right there. Now let's talk about the rise and run. From D to B, I would have to go like this. There's my rise, and there's my run. So that's a rise of 4, positive 4, and a run of 8. Okay, so rise over run is 4 over 8, and that reduces down to 1/2. Okay, notice that these are opposite and reciprocal. Alright, 2 is like 2 over 1. The reciprocal is 1 over 2. So those are reciprocals. 1 is negative, 1 is positive. So they're opposite. That's opposite and reciprocal. So now it's time for the summary statement. And here it is. Since the slopes are opposite and reciprocal, the diagonals are perpendicular. And that's the special property about the diagonals of a rhombus that I was trying to prove. Okay, let's do that same basic thing one more time. So this time in problem number 18, we're dealing with a kite. So first we're going to prove it's a kite, and then we are going to verify a special property of a kite. Okay, now the definition of a kite is that we have consecutive sides that are congruent, but not opposite sides. Only the consecutive sides. Okay, so if we're talking congruent, we're talking length. So that means I'm going to find all 4 lengths, and I'm going to show that I have 2 pairs of consecutive sides congruent. So that's my strategy. Let's write that down. So here's my introduction. I will show that 2 pairs of consecutive sides are congruent, but not all sides are congruent, because that would make it a rhombus. Alright, now it's time for the body of my proof, which is a bunch of calculations. So I'm going to calculate the lengths of all the sides, but based on the picture, I predict that KL and LM are going to be congruent, and I predict that MN and KM are going to be congruent. So I'm going to kind of go in order to show that. So I'll do KL and LM. Those should be the same. And then I'll do MN and KN, and those should be the same. But they won't all be the same. Okay, so first KL. So let's do a little Pythagorean Theorem. I see 1 and 3. So this is going to be the square root of 3 squared plus 1 squared. Let's see, that's 9 plus 1, so that's 10. So that's going to be the square root of 10. So that's the length of KL. Okay, now let's do the length of LM. Okay, so here comes LM. More Pythagorean Theorem. So here's my little right triangle. I see 1 and I see 3. So this is going to be 1 squared plus 3 squared. Alright, same numbers, of course I'm going to get radical 10. So sure enough, I've got my first pair of consecutive sides that are congruent. So now let's go for the next pair. Alright, so how about MN? Okay, so a little bit of a bigger triangle here. Okay, so that's 5 and 5. So make sure I'm counting right. Okay, so it's 5 squared plus 5 squared. Well, that's 25 plus 25, so that's 50. Square root of 50. Okay, let's do the same thing for NK. Okay, this is a tall, skinny triangle. I see 1, and I see, let's see, 4, 5, 6, 7. I see 1 and 7. Alright, so that's going to be 1 squared plus 7 squared. Well, 1 squared is 1, and 7 squared is 49. So that's 1 plus 49. Guess what? That's 50. So I have 2 pairs of consecutive sides that are congruent, but they're not all congruent, so that makes this a kite. So I'm just going to write down that conclusion that I just said. And there you go. Since 2 pairs of consecutive sides are congruent, but not all sides are congruent, KLMN is a kite. So see, I have my introduction, my body, which is the calculations, and then my conclusion. Alright, last thing. Now we need to prove verify one property about the diagonals of a kite. That's going to be the same as what we had for a rhombus. The most important property of a kite is that the diagonals are perpendicular. Okay, and once again, if you want to show that diagonals are perpendicular, if you want to show that any segments are perpendicular, you show that their slopes are opposite and reciprocal. So that's our strategy. That will be our introduction. So there it is. My introduction is I will show that the slopes of the diagonals are opposite and reciprocal. So the diagonals are, the first diagonal is KM. So let's talk about the slope of that. Alright, so slope KM. Alright, what's going on there? Let's talk rise and run. So from K to M, I'd have to go down 2 and right 4. So that's -2 is the rise and 4 is the run. Okay, so I've got -2 over 4, which simplifies down to -1/2. So that's the slope of KM. Alright, now the other diagonal is LN, or NL. Okay, so here's the other diagonal, is this guy. Okay, so let's find that slope. Alright, so let's talk rise and run. So from N to L, I'd have to go like this. This is my rise, and this is my run. So let's see. So that's a rise of 8 and a run of 4. Rise over run, that's 8 over 4. Which reduces down to 2. So that's the slope of NL. So notice that these are opposite and reciprocal. Alright, the reciprocal of 2, like 2 is like 2 over 1. So the reciprocal is 1 over 2. Alright, so they're reciprocal. This one is negative, this one is positive, so they're opposite. Opposite and reciprocal. So that means that they are perpendicular. So I'm just going to write that up in my conclusion. Since the slopes of the diagonals are opposite and reciprocal, the diagonals are perpendicular. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.